This is an intermediate Python programming tutorial for beginning or intermediate Blender users. I'm using version 2.63a, and it's a follow-up to the basic Python programming tutorial that I've recently posted on YouTube. Alright, so if in the previous lesson we had plotted these cubes around a circle at 45-degree angles or at 0.785 radian angles, and based upon the location of the cursor where we selected it. So let's go back to our programming screen and take a look where we were. And let's just do a little upgrading to this. And it's partly a math lesson and it's partly a programming lesson, because as time evolves, the math is going to become much more important in these lessons if you really want to do really cool things. But I'll work back and forth between the design and the programming, because I use both for good reason. You know, as in this case, say I've added, you know, the cubes to the scene. Well, then you can go right back into Blender and you can do whatever you want. You might add a particle system to it, or then you might come in later and add particle systems to the cubes as you're putting them in the scene programmatically. So there's lots of opportunities to work. It just depends on your preference. I happen to like to code more than I like to just design. Do I like to design? It's a tough call. All right, so let's see. So in here we had gone through here what these were variables from the previous lesson that I had actually not taken advantage of, but I do have a command in here that I can take advantage of, and I'll do that just now. So what I'm doing here is it's a command bpy.ops.transform.resize and value. So let's just go see what that does. Let's just, in one case, we might click a cube, hit the S key, and I'll just see if it scales in here on that. Alright, so I scaled it. Now let's see what the menu item says. Well, there it is, bpy.ops.transform.resize, and then parentheses value equals, and it tells me the value. And then there's all these other options, there's constraints and everything else, but all I'm using is the basic parameter right here, the resize value. So in this case, you'll notice that this is going to represent X, Y, and Z, so I'm going to scale it. 1 is the default size for a cube, and you'll just see that if you just add a cube to a scene. But then I'm just going to scale it down to 0.2, so I'm cutting it way down a size in 0.01, 0.01. I had done that earlier for some reason. I don't remember why, but we're going to try it. And we'll just add this to the scene for the moment. And I'll go look at it from above. I'll put the cursor here. I'll go see where it is. Now maybe I'll put the cursor over here in a little more light. And then I'll run the script. Uh-oh, don't tell me that cursor is below the screen again. Oh no, it's probably not. I just can't see it. Maybe I made them too small. So let me zoom in. Well, so there they are. So, well, I guess I don't know why I was doing this before, but what they end up being is really long, thin rectangles like that. Alright, so obviously too small. So let's just make them, I don't know, 0.8 and 0.8 and 0.2. And let's put another one there. Let's run that one. And then make sure I'm in ortho mode so I can see what it looks like. 7 ortho like that. And then it must be scaled. Yeah, they're flatter like that, because 0.8 in X and Y, and then 0.2 in Z, like this. So kind of that gives you an idea. All right, so now let's upgrade this code a little bit more. Well, one thing I had done, let me expand the screen just for a second. When I had set up the scene initially, I'd taken all my lights and everything and I'd put them on another layer. So you can see there's, my number 2 layer was active, so everything just went on the number 2 layer as well. So that's actually going to goof me up a little bit. So I'm gonna erase some of these guys just to clean the scene out a little bit. I'll delete those. I got rid of a light. Okay, get rid of that guy. Those guys, oh, I'll get rid of those guys. I'll get rid of that light too. I don't really need it. And I'll get rid of that one as well. And I'll just leave that in there for the moment. And then I'm just going to add a regular light to the scene just to brighten the thing up. Put a Hemi light. Whoa, those are really bright. But, well, that gives you an idea. All right. So now what we'll do instead of placing the objects relative to the cursor location. Let's change it up. Let's just get rid of this. This will help you see the mathematics maybe a little bit cleaner. And z. So, well, let's try for starters. So, in this case, x is going to be just going to give it returning the data of the traditional sine and cosine functions, all right, based on this radial distance. So, but the z value isn't set, so let's set z in advance as something like z is equal to 1.0, slightly above the surface, depending upon where this guy's located. Let's see if that's, click N. I actually have this set at 1.49, so we'll just make him 0.5. And so then these will show up above the surface, and I don't actually need to put z in here. I'll just put x and y, and z is going to be set to 1.0. But down here, after I increment the angle, I'm going to make z plus equals 4.0. So what that should do is that should go around the circle, and it should increment at every 45 degrees, or 0.785 radians. It should actually rise up from the center. I don't know. Let's see. Let's run it. Okay, so let's take a look close. So there it is. It started from the center. Let's verify that. Shift S and snap cursor. Put the cursor to the center. So it says S. So there it is. The first one's going to be 0 and out at a radial distance. Let's go from above in ortho mode, like that, and you can see the first one, if you look straight in ortho mode, was right over here to the right. The next one is raising up a little bit on Z, and a little bit like that. So then you can place things accordingly how you want. But now let's even make it a little bit different. Let's change that up. Let's go back into here, and let's nest this in a loop. So in this case, let's see if we can do this. Let's try and place each one of these on its own circle. So we're going to nest this within a loop. So let's see if we can pull this off. So we'll tab that here. I'm just going to, this is going to be my inside nest for a loop. And then up here, I'm going to have a different while loop. And I'm going to say, I'll just say while outside theta, just differentiate the variables, is less than 6.28. And up here I better have an outside theta variable so I'll start him at 0 as well. And I'll make an outside radial distance. Radial dist equals, we'll put him at I don't know, 8.0, something like that. Remember, put those further apart. 15.0. All right, so outside theta, so it's less than 6.28. It's going to come in here, and then it's going to do all the circles in here at this location, but it's going to be that's going to theoretically place it at the center, but it's going to have to be offset from this here. So let's continue. Let's see. That's going to be there. This theta is, I know I'm going to have to come down here outside of the loop, is going to be, so outside theta plus equals 2 pi over 8. 2 pi over 8. And in this case we won't, oh yeah, let's, the outside, once we pop out of the loop, we're going to put our z value back to 0, like this. And so we come into the loop, outside theta gets incremented, goes all the way around. This calculates this, but it's going to calculate it and put it right at the center. But we need it to be based upon this thing. So outside theta's got to have its own. So we'll say x out. That's going to be our new name. Is x out is equal to outside radial dist times cosine outside theta. and y out is equal to outside. I'm just winging this on the fly. I'm not sure it's going to work or not. We're going to find out. Outside radial dist times sine of outside theta, and let's see, we don't really care about z, but what we do is we're going to add, since those are growing around the circle on the outside, the large circle on the outside, and that's where we want these to be, so we're going to have to translate it based on that. So x out plus that, and y out plus that, and then the location is there. I don't know, that might work. Save it. I'll save it. We're going to try it. Let's go. Yeah, we'll just run it. Error. 6.2 outside theta is less than 6.28. Let's see. So invalid syntax. In fact, let's go take a look at the console window. This is a good indication. Console window says, whoops, I'll bring the console window into view. It says line 24, 6.28. Oh, yes, a common programming error. I forgot the colon at the end of the line. Okay, let's try that. Let me save that one. Save, run it. Something happened. Python script fail. No, that must be the earlier Python script fail. I see something in there. Let's go look closer. Oh, well, now I see something on the outside. That must have been the original one there that I had placed. Let's see. I'll forget n. Let's see where this is actually located. N is at x is at 20, 16. So the z's are, so something didn't quite work. Let's go back and see what I goofed in the code real quick. Outside theta. Let me see. Alright, if I can't find it, I'm going to cut the video out real quick and I'll come back as soon as I find it. But let's see if we can see it. It's got to be theta 2. Outside theta plus equals 2 pi over 8. Better make this guy here. That means he sets it back to z after he leaves the inside loop. Otherwise he's going back to z. So looks like maybe he's just trying to keep going out of the loop. Alright. Run. Yeah, there they are. They're there. Son of a gun, they're there. There's just those little skinny guys. What did I do? 0.8 resize value is... Alright, we're not going to resize them for the moment. I think my resize value must be messing it up. And then run the script. And there's that one. So there he is. Okay, so what I forgot to do is, in this case, I'm in here, and so I needed to reset theta in here as well. So theta has to be set to 0.0, because what happened was the outside loop happened once, the inside loop happened, it incremented up till it exceeded 2 pi, and then it popped out of the loop. So this loop never executed any more times because I hadn't reset theta to 0 like this, and so didn't need to set it back here. Alright, so now when I run it, let's see, and there they are. So if we look at it from above, then what it's done, oh, maybe it's not the coolest design, but what basically takes an instance of each one of those curves that are rising up, and it places them around a circle at their own location. In fact, let's see if we just, let's put one way out. Let's just run another one, but we'll make outside theta, the outside radial distance as, say, 35. We'll put it way out there. Let's see what happens. And run the script. And there's another sequence of them out there, right, on the outside edge. Alright, so that's how you do the nested loop, and that's how it's really also some practice on jogging your memory for your trigonometric functions, sines and cosines. They're just pretty powerful, huh? You can do a lot of fun stuff with those things. And okay, well, that's it for this lesson, and I'll see you in the next lesson.